Today we're going to review for a quiz. The first question we're going to do, number 1, if I give you something that looks like this, p to the negative 6, and it says write an expression that is equivalent to this using a positive exponent. Now we've had this on a quiz before, but a lot of people are still having trouble with this. So if you have a negative exponent, it is not simplified. So to simplify it, all you have to do is move it to the bottom of the fraction and make it positive. And there is the equivalent expression using a positive exponent. Number 2, it's going to ask you to find the equation of a line when you know the slope of the line is negative 4 and it passes through the point negative 1320. So we want to find the equation of a line that has a slope of negative 4 and goes through the point negative 1320. Well, what do we have to find the equation of a line? We have to find m and b. Well, we already know m is negative 4. We just have to find b, our starting point, or a y-intercept. So we're going to use the equation that has m in it and that has x and y, because we have x and we have y. So we're going to use the formula y equals mx plus b. All right, let's substitute in what we know. Y is 20, m is negative 4, x is negative 13, and we add b, and we don't know what that one is. That's what we're looking for. So all we have to do is solve this equation for b. So I have 20 equals negative 4 times negative 13 is 52 plus b. I want to solve for b, so I'm going to move 52 to the other side. And I get b equals 20 minus 52, which is negative 32. So I have b, which is negative 32. I have everything I need right here to write my equation. So I use this rule again, and I say y equals m, which is negative 4, times x, plus b, which in this case is a minus 32. There is the equation of a line that has a slope of negative 4, and it goes through the point negative 1320. If you need to pause at any time, please feel free to do so if I go a little bit too fast. Next page. Number 3, I want you to simplify this problem. If you have 3x to the 7th y times 7x y to the 9th, I am multiplying these two monomials together. I see the 3 and the 7 are my coefficients, so I'm going to go ahead and multiply those, and I get 21. Then I look and I see, oh, I have 7 x's here and I have 1 x here. So how many x's do I have total? Well, when I multiply like bases, I add the exponents. So I have x to the 7th and x to the 1. That will equal x to the 8th. Then I look at my y's. I have 1 y here and I have 9 y's here. So when I multiply like bases, I add my exponents. Even though I don't see an exponent here, there's really a 1 there because I have 1 y. And I have, how many y's do I have? I have y to the 10th. I have 10 y's. And that is my answer. Okay. Number 4, I want you to solve this equation. You have the absolute value of 5x minus 6 is equal to 14. How many answers should we get on this problem? Well, when you have absolute value, you notice the absolute value is by itself and it's equal to a positive number. So we should get 2 answers to this question. To get rid of the absolute value, I'm going to write this problem 2 times. To take it out of the absolute value, I say 5x minus 6 is equal to the opposite of this number right here. This is a positive 14. I'm going to make it a negative 14. Or I'm going to write it again, exactly how it looks without the absolute value. So notice the part inside the absolute value does not change. The 14 I write as negative first and positive second. Now I can solve both of these equations. I'm going to add 6 to both sides. I get 5x is equal to negative 8. Divide both sides by 5. And I get x equals a fraction, negative 8 over 5. Or I'm going to add 6 here to both sides. And I get 5x is equal to 20. I then divide both sides by 5. And I get x equals 4. So there are my 2 answers. And it's okay to get a fraction answer. All right, next page. I want you guys to simplify this problem, number 5. If you have 9 x squared y to the 13th power divided by 27 x to the 10th y to the 7th, and the whole thing is raised to the 2nd power. Now, one way you could do this problem is just take everything inside the parentheses and raise it to the 2nd power. But you're going to make your 9 an 81 and you're going to make your 27 a really big number. So let's simplify inside the parentheses first, and then we will raise it to the 2nd power. So we'll do everything, simplify your fraction inside the parentheses, and then you'll square everything. So inside my parentheses, and go ahead and rewrite your parenthesis, because if you forget, you'll forget to square it. So make sure you put your parentheses on there. So make a big fraction bar. We look at 9 and 27. 9 goes into 27, so 9 goes into 9 one time, and it goes into 27 3 times. So I have a 1 on top, which you don't have to write, and I have a 3 on the bottom. 9 over 27 reduces to 1/3. Now, look at your x's. Where are most of your x's? Most of your x's are on the bottom, so your x's are going to end up on the bottom. You have 2 x's on top and 10 on the bottom. So what happens when you cancel out 2 x's from both of them? You're left with 8 x's on the bottom. All right, on top, my y's. I have more y's on top. I have 13 y's up here and 7 on the bottom. So you could just subtract your exponents and say 13 minus 7, or you could say, where are most of my y's? Most of my y's are on top, so I know I'm going to have the leftovers on top. And if I cancel out 7 y's, how many y's will I have left on top? I'll have 6. So I have 6 y's on top. All of that is raised to the 2nd power. Now, when I square 1, I get 1. So I don't even have to write the 1. So I'm going to draw my fraction bar, and I'm going to raise everything to the 2nd power. What is y to the 6th? What is y to the 6th raised to the 2nd power? Power to a power. I multiply my exponents. So I get y to the 12th. And on the bottom, I have 3 raised to the 2nd power. Remember, 3 to the 2nd power is 3 times 3. It is not 3 times 2. So I get 9. And then I have x to the 8th power raised to the 2nd power. Power to a power, I multiply my exponents, and I have x to the 16. I cannot simplify anything else because I have y's on top and x's on the bottom. So this is my simplified answer. Okay, I'm going to go ahead and turn the page. Number 6. I want you to solve this equation for x. So I have x plus 6 in parentheses times x minus 1 is equal to x minus 4 in parentheses times x plus 5. Notice I have two binomials multiplied together on both sides. My goal is to find out what x equals. So I need to get rid of the parentheses, and then I'm going to solve for x. So I have to use distributive property twice. So I'm going to take this x, I'm going to multiply it by everything in the second set of parentheses. X times x is x squared, because when I multiply like bases, I add my exponents. X times negative 1 is negative x. 6 times x is plus 6x. And positive 6 times negative 1 is negative 6. So I got rid of my parentheses. That is equal to the other side, which I'm going to do the same thing. I'm going to say x times x is x squared. X times positive 5 is plus 5x. Then I'm going to take my negative 4 and I'm going to distribute it. Negative 4 times x is negative 4x. And negative 4 times positive 5 is negative 20. Now, when you look at that equation, what is the same on both sides? I have an x squared on both sides. So if I subtracted this x squared and moved it to the other side, they're just going to cancel. So let's just cancel them out. Collect like terms. On this side, I have like terms right here. I get 5x minus 6 is equal to, collect like terms right here, 5x minus 4x is 1x minus 20. Okay, now I have each side as simplified as I can get it. Now I'm going to move my variable. I'm going to move my x to the other side by subtracting it. And here I get 4x minus 6 is equal to negative 20. I now have a two-step equation. I'm going to get rid of whatever's added or subtracted first, so I'm going to add 6 to both sides. And I get 4x is equal to negative 14. Now, 4 is not going to divide in evenly. That doesn't mean we have no solution. We're going to get a fraction answer. So we divide both sides by 4. My 4's cancel, and I get x equals, my negative sign stays. And what can I divide out of 14 and 4? I can divide the top and the bottom by 2, and I get negative 7 over 2. And there's my answer. Okay, let's move on. Number 7. Now, number 7's a newer concept that we learned right before I left. All right, suppose you have a bouncing ball, and the ball is dropped from 800 centimeters, and it rebounds to 580 centimeters. I'm going to ask you two questions. Question 1, find the rebound ratio. Okay, I want to find the rebound ratio. Remember the formula. Rebound ratio is the rebound height, the smaller number, divided by the bigger number, which is the starting height. So if I want to find the rebound ratio, my rebound height was 580. So I'm going to put that on top, 580 centimeters. On the bottom, my starting height, I started at 800 centimeters. Now remember, when I divide those, my centimeters cancel out, so I don't have any units on my rebound ratio. On my calculator, you plug in 580 and you divide it by 800, and you're going to get a decimal. And our decimal in this case turns out to be 0.725. That is my rebound ratio for this situation. Now, the second question they're going to ask you is they want you to find the rebound height after the fourth bounce. Now there's actually two ways you can do it, and I will show you both ways, and you will probably figure out that you actually like one way better than the other, and that's fine. So you can do it however you want. Just show me what you did on your quiz. Okay? Well, first of all, if we make a chart, remember our chart would be the bounce number here and the height of the ball here. What happens when we haven't bounced at all? What did we start with? We started with 800 centimeters. After bounce 1, now we want to go all the way to bounce 4. And will answer the question once we get to 4. We know that the rebound height after one bounce was 580. But let's just check that by multiplying by our rebound ratio. On your calculator, you're going to plug in 800 and you're going to multiply by 0.725, and we should get 580, which we do. So that is how high the ball is after the first bounce. Now we want to find out when it bounces again, what happens after the second bounce. So I'm going to multiply by 0.725 again, and I get 420.5. And I think that one actually doesn't have a decimal that continues. So I just wrote down exactly what it has, but whatever the decimal is on your calculator, leave it on there and just keep multiplying by 0.75. You don't have to write down the whole decimal when you write it in your chart. All right, times 0.725 again, and I'm going to get 304.86. And I think on that one, I just wrote the first two numbers after the decimal. I did not round it. Then I'm going to multiply by 0.275 again, and I get 221.02 centimeters. After my fourth bounce, it's going to be 221.02 centimeters high. Now that's a lot of work to find the answer. Is there a faster way? Can we write a rule and then just plug in 4 into the rule to find out how high the ball will be after the fourth bounce? Well, this is, since I'm multiplying by 0.725 every time, this is an exponential equation. So I'm going to write y equals, I'm going to have my starting value times my multiplier raised to the number of bounces. So I say y equals, the height equals the starting value. Where did we start? We started at 800 centimeters. We multiplied by 0.725 every time it bounced. That was our multiplier. And we want to know what happens on the fourth bounce. So we put 4 in for B. Now when you plug this into your calculator, remember, put this part in first. Put 0.725. Raise it to the fourth power, push your caret button, and raise it to the fourth power, and then hit enter. And then right away, just multiply by 800. So when you do that, what do you get? Well, you get 221.02, and it does continue, centimeters. And we got the same answer, but we got it a lot faster by using our rule than using our chart. On the quiz, I don't care which way you do it. If you want to do it both ways to double check yourself, that's fine. But make sure you show me what you did. And that's why you will want to use a calculator during the quiz. All right. Let's try another one. We have 2 more problems. Number 8. I want you to solve this system. Y equals negative 2x plus 31, and y equals 5x plus 3. Now, the way this is set up, I would use equal values method. You could use graphing method, but it's probably a lot more accurate if you would use equal values method. You could also think of it as substitution if you would like, and substitute this 5x plus 3 into the y that's up here. But I'm going to think of it as equal values method. So if if this equals y and this equals y, then these two things are equal to each other. So I'm going to write my new equation. I have negative 2x plus 31 is equal to 5x plus 3. Because they're both equal to y, they're equal to each other. And now all I have to do is solve for x. And I'm going to move my 5x over. I get negative 7x plus 31 is equal to 3. Then I subtract 31 from both sides. And I get negative 7x is equal to a negative 28. Divide both sides by negative 7. And I get x equals 4. Are we done? Well, remember, we're solving a system. So if we're solving a system, we are looking for a point of intersection. So we are only halfway done. We just found our x. So that is 4. We need to find the y that goes with it. So pick one of these equations and substitute in your 4. So I have y equals negative 2 times 4 plus 31. Simplify, I get y equals negative 8 plus 31. And when I simplify that, I get 23 for y. So my point is 423. And you see why graphing, it would have been a pretty big graph if our point of intersection was at 423. So that's why equal values method is probably the best option. All right, we have one more problem. We are going to graph two equations on the same graph. That's all they want you to do is just graph them, and then you will label each one with their equation so I know which one is which. Okay? So, our first problem, this is problem number 9. Our first problem is y equals negative 5x plus 2. If we want to graph this equation, we need to find m and b. My slope, and I'm going to write it as a fraction because I'm going to use it to graph, is negative 5, but I'm going to put it over 1. And b is positive 2. So when I graph this, I go to my graph and I go to the this is my y-intercept. So I'm going to go to the y-axis at positive 2. And from there, I'm going to use my slope. And this says go down 5 to the right 1. 1, 2, 3, 4, 5 over 1. Or I could say this is 5 over negative 1, still equal to negative 5. From my starting point, I can go up 1, 2, 3, 4, 5 over 1. And now I'm going to draw my line. Try to make it straight, better than that. And then I'm going to label it because I'm going to be putting 2 on the same. So this is y equals negative 5x plus 2. Part B, the second equation. The second equation they want me to graph is y equals 3x minus 4. My slope is going to be 3, so I'm going to write it as 3 over 1. And my b equals negative 4. So let me put my points on there. I'm going to start at negative 4, 1, 2, 3, 4 on the y-axis. And from that point, I'm going to use my slope, rise 3, run to the right 1. So up 3, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. And draw your line. So I label that y equals 3x minus 4. And there we have the two problems just drawn on the same graph. We weren't looking for the point of intersection. Notice where these cross, it's not exactly on a point anyway. That's not a fraction or a decimal. So we just wanted to graph the two lines and we're done. All right, that's what will be on the quiz. So what I want you to do now is I want you to put all your notes away, all your papers away, all your folders away, and I want you to put your phones in your backpack, and I want you to move your backpack against the wall. And then I want you to spread out, and I want you to get your folders up, and you can get a calculator if you don't already have one, and just make sure on your quiz, there's problems on the back, make sure you show all your work. And that is all for today.